we're now moving on to measuring angles in another way, and they're called radians, okay? So it's still part of the trigonometry topic. You'll notice on your calculator you have a degrees mode and a radians mode. Have you ever noticed that? But you'll see this different mode here, and the setup button, setup. If I press 0 for degrees, and see we've got degrees, radians, and grab. Another way of measuring your angle size is radians, okay? And we're used to using degrees, okay? So what is a radian? A radian is the angle made when the radius is wrapped around the circle. So for example, if this is the radius here, and this, if I take that length and wrap it around the circle, and then I come back down here, this angle here formed is called 1 radian, okay? Okay, now, so 1 radian is about 57.2958 degrees. You don't have to know that. So the radian is a pure measure based on the radius of the circle. So if this is the radius, and then I do that same length around the circle, this angle here is 1 radian. You can see, yeah, it's just that length when the radius is wrapped around the circle. So that angle in there is a radian, okay? So we've already spoken about that. Okay, now why does 1 radian equal 57.2958, etc. degrees? Okay, so if we take this radius here, okay, and we wrap it around the circle 3 times, it's almost like, you know how circumference is pi d? It's a similar sort of activity when you were first introduced to circumference is pi d in year 8. Did they ever take the diameter and show that you get 3 and a bit diameters around the circle? Did you ever do that with a piece of string? You measured the distance around the circle circumference and you divided it by the diameter and you got pi. So if we just look here, okay, so here is my 1 radian, 2 radians, 3, and that little extra bit, it actually, if it's measured, it actually ends up being pi, okay? So if we do that activity, and we can see that we know that pi is the number 3.1415, etc. In a half circle, we've got pi radians. So we've got that 1, that 2, that 3 and a bit, 3.1, and it's actually measured to be 3.14159, etc., which happens to be the number pi. So in a half circle, we have pi radians, because remember that's 1 radian, 2 radians, 3 radians and a bit. But that 3 and a bit actually equates to pi. And we know that that angle is also 180 degrees. Because you know how pi is 3.141, right? So what they've found is that this angle is, we know it's 180 degrees, but in terms of radian measure, it's also the number pi, okay? So pi radians is 180 degrees. That is what we need to just remember. Okay, that pi radians is 180 degrees. Now today we're going to practice going from radians to degrees and from degrees to radians. Okay, so girls, we're going to do this in our books anyway, but you know how 30 degrees, you know how we've got 30 degrees? If you relate that to 180, isn't 30 180 divided by 6? So that's why 30 degrees in radians, it's 180 divided by 6, so it's pi on 6. Do you get that? Look at 60 degrees. Isn't 60 180 divided by 3? So 60 degrees is pi on 3, because pi radians means 180 degrees. So if you know that pi is 180, 60 degrees is pi on 3. 90, isn't that 180 on 2? So it's pi on 2. 180 degrees is pi. 360 degrees would be 2 pi. We're going to write this in a minute. 45. Don't 4 45s make 180? So it's 180 divided by 4, or pi divided by 4. Okay, 270 is 1.5 lots of 180. It's 180 plus another 90. So it's 1.5 times 180. So it's 3 over 2 times 180. All right, now in a full circle, let's say I've got that radius there, and if I wrap it around the radius, if I wrap it around the circle, I get 1, 2, 3, 4, 5, 6 and a bit, and that 6 and a bit ends up being 2 pi if you did take it and measure it yourself. So you know how pi is 180 degrees? 2 pi is 360 degrees. So a full revolution, we know, is a full revolution. What I'm doing there is 360 degrees. But we know also that a full that's in degree measure. In radian measure, a full revolution is 2 pi. Okay? The angle made when the radius is wrapped around the circle. So that's the radius. If I then take that length and wrap it around there, come back here with another radius, this angle that's subtended there is called a radian. Okay? We need to know is that pi radians is 180 degrees. So we say pi radians, so we know we're measuring in radians. And we know we're measuring in degrees because I've got the little degree symbol. Is 180 degrees. And 2 pi radians is a full revolution. It's 360 degrees. Okay? Common angle in degrees and radians. So, just a little table. So, for example, 30 degrees, because we know, because you think to yourself, how do I make 30 out of 180? Isn't it 180 divided by 6? Do you get that, girls? So I say to myself, 30 degrees. I know in my head that that's 180 over 6. So I'm just going to put that little working column, that little working thinking column. But in radians, it's pi on 6. You okay with that? So 30 degrees is pi on 6 radians. I'll do 60 next. So 60, isn't that 180 divided by 3? That's how I get 60. So that's actually pi on 3 radians. So 60 degrees is pi on 3 radians. Another one, 45 degrees. 45 and 45 makes 90. So that's 180 on 4. So I can say that 45 degrees is pi on 4 radians. There is a formal method where you convert from degrees to radians. I'll do that in a minute. But I'm just doing the common angles. Okay? Another one would be, and how you can remember them. So this middle column is how you remember them. 90 degrees. Isn't that 180 divided by 2? And we know that 180 degrees is pi. So instead of saying 90 degrees, I say pi on 2 radians. Okay? We know what 180 is. Let's say I had 120 degrees. All right. I think, isn't 120 2 lots of what? 2 lots of 60, isn't it? That's how I think of it. I think of it as 2 lots of 60. So it's 2 lots of, and isn't 60 180 over 3? So 2 lots of pi on 3. So it's 2 pi on 3. How are you with that, girls? 120. 120. So girls, once you know that 30 degrees is pi on 6, 60 degrees is pi on 3, 45 is pi on 4, if you remember those three, you can do 120, 150, 210, 240, etc. By just using this approach, for example, that 120 is 2 lots of the 60 degree. Okay? So the main ones you want to have in your head is that 30 degrees is, it's 180 divided by 6, so it's pi on 6. These are the main ones you want to have in your head. 60, we know, is 180 divided by 3, so it's pi on 3. So if you remember those, that 30 is pi on 6 and 60 degrees is pi on 3, and it's not even remembering. The only thing you have to remember is that pi is 180. One thing. 60 is 180 divided by 3. And the other one you might want to remember is that 4 lots of 45 make 180. 45 and 45 is 90. So 45 degrees is pi on 4. So if you know those three, you can do all these others that I'm about to do. Okay? So 120 degrees, you could do it as 2 lots of 60, or you could do 4 lots of 30. What about 150 degrees? See, I think, isn't that 5 lots of 30? Do you get that? 5 pi on 6. So it's 5 times pi on 6, which is 5 pi on 6. Now I am going to show you the formal method. This is just using mental methods to do it, which I really like. Okay. What about something like 210? How are you going to get 210? Think of your times tables. You need your 3 and your 6 times tables. Yeah, it's 7 lots of 30. So what would that be? 7 times pi on 6, which is 7 pi on 6. Something like 240, girls. What are you going to do? 3 times 30s or 60s? How many lots of 60? 4 lots of 60, which is 4 times pi on 3, so it's 4 pi on 3. All right, we know all right, so we're going to do, let's do 270. Isn't that 3 lots of, oh, sorry, and the other one you want is that 90 degrees is pi on 2 as well. Okay. So what's 270 going to be? 3 lots of 90? So it's 3 pi on 2, because 90 is pi on 2. Oh dear, yes, I have that one. 135, what's that? Yeah, it's 180 minus 45, or it's 3 lots of 45. Yeah, so we could do 3 lots of 45, or someone's just said 180 minus 45. Yeah, it's like fractions. It's fractions work. If you do 180 minus 4, so let's just do 3 lots of 45, which is what? 3 pi on 4. Or if you do it as 180 minus 45, it would be pi minus pi on 4. Now that's 1 pi minus a quarter pi, which is 3/4 pi. So we're gonna move into this idea soon. Okay, we have to get into this idea soon, which is 3 pi and 4. So, you know, you can think of 135 many different ways. You can think of it as 3 lots of 45, or you can think of it as 180 minus 45. We know that 180 degrees is pi. We know that 45 degrees is pi on 4. So it's really, I'm just looking at the fractions, 1 minus a quarter. It's like x minus a quarter x is 3/4 x. Pi minus a quarter pi is 3/4 pi. 225. Look, not many of you really know your 45 times tables, all right? So I'd be thinking of this one as 180 plus 45, which is pi plus pi on 4, right? So I'm thinking 180 plus 45, that's pi plus pi on 4. Isn't that 1 pi plus a quarter pi? What's 1 1/4 as an improper fraction? You okay with that, girls? That's 1 1/4 pi. Now you don't go writing it like that. You go improper fraction. 4 times 1 is 4 plus 1 is 5. So 5 pi on 4. Okay, girls? Or you can, you know, if you know that it's 5 lots of 45, good luck. All right, 330. You could say, we can do this 2 ways. We could do, look, which times tables is 33? 11 times 3? 60 minus. Very good. And we're going to do that as well. So 330, you can do 360 minus 30. Now, what's 360 in radians? 2 pi minus, what's 30 degrees? Pi on 6. So that's 2 minus 1/6. As in terms of fractions, what's 2 wholes minus 1/6? Isn't it 1 5/6? Which is, we don't write it like this. It's 11 pi on 6. Now you can think of it like that, and you have to when we start solving equations. See, we're going to be solving equations using radian measure as well today. Or you can think of it as 11 times 3, 30. 11 lots of the pi on 6. Now what about 300? You can do it 2 ways. So you could do 11 lots of 30, which is 330, so 11 lots of the pi on 6. What could you do 300? How could you do 300?
360 minus.
Yep, you can do 360 minus 60, which is 2 pi minus pi on 3. Now, with working with fractions, it's 2 minus a third. Do you get that, girls? Which is 1 2/3, but we don't write it like that. 5 pi on 3. You know what you've got to do? You've got to think of 2 pi as 6 pi on 3. Because we're in thirds. 2 wholes is 6 over 3. So it's 6 over 3 minus 1 over 3. Okay, so, or you could do 5 lots of 60, couldn't you? Which is 5 pi on 3 as well. So 2 ways to do it. Let's do 315. How do you get 315? 360 minus 45. So that's 2 pi minus pi on 4. So we're looking at 2 minus a quarter. What's that? 2 minus a quarter. Come on. 1 3/4, which is improper fraction. Year 7. I know that. Instead of now saying, what's the sine of 30 degrees, we'll say, what's the sine of pi on 6? And you'll just say to yourself, sine of pi is 180. It's like I'm being asked, what's the sine of 30? Okay, and that's what we do. Also, when we solve equations, we're going to go and solve equations now using radians. So instead of giving my answers as, say, 60 and 210 are my answers, I'll have to write them in terms of radians, for example. Okay? For converting numbers like 30, 60, 45, 90, etc., anything that's a multiple of 30, 60, 45, but not every angle is 30, 60 or 45, etc. So I might ask you to convert 10 degrees or 5 degrees to radians. Let's say I say to convert degrees to radians. So girls, you multiply by, now this is how I remember which way to do it. When you're converting from degrees to radians, because you're converting into radians, you multiply by pi over 180, right? And to convert, so there are 2 rules. Radians to degrees, you multiply by 180 over pi. So a lot of people get confused. Which one do I do? I just remember if I'm converting to the radians one, I put the radians on top and then the degrees on the bottom. And if I'm converting from radians to degrees, I put the degree on top and then the radian on the bottom. The reason is you get cancelling. You get cancelling out. And I'll do some examples now. So degrees to radians multiplied by pi on 180, you put the radian on top and then the degree on the bottom. And radian to degrees, put your degree on top and your radian on the bottom. Now, really, what is pi anyway, girls? So you're really just multiplying by 180 on 180, which is 1. But you're writing the 2 angles in different formats, so you're actually not changing its value, you're just changing the way it looks. It's almost like equivalent fractions in a way. And 180 degrees over pi is just multiplying, you've got the 180 degrees in the angle measure, in the degree measure, over pi, which is 180 degrees anyway, in radian measure. So just some examples. Convert to radians, the following. 10 degrees. See, some of you know, isn't that just, so we'll use their method. 10 degrees times, what do I times by? 180 on pi or pi on 180? No, I'm converting to radians. Sorry, so you put your radian first. Pi on 180. The other reason is, girls, see 10 degrees over 180 degrees, you get cancelling of degree units. So when you're converting to radians, you put your times by the radian over the degree. You write the radian one first. Now, what's 10 over 180, girls? Cancel, cross off some zeros. What is it? Pi on? 10 pi on 1 pi on 18, so it's pi on 18. Don't you think to yourself, isn't 10 180 on 18? If you think of it. So you get cancelling between the 10 degree and the 180 degree. Something like 5 degrees Isn't that 5 degrees times pi on 180? So what you would do on your calculator, you don't put the pi in. You put the, oh, let's see actually, if yours keeps your pi's in place, just go 5 pi over 180. I would just do 5 over 180 in my calculator. What are you getting? Is it in terms of pi? Because it should be pi on 36. Girls, you getting pi on 36 or it's giving you a... So yeah, if you don't put the pi in, you will get 1 on 36 because the pi stays there. We're really just simple. So that's 5 pi on 180. But we just want to we want to simplify 5 on 180, which is 1 on 36. So it's pi on 36. Okay, something like, I don't know, 220 degrees. Converting that to radians. So it's 220 times pi on 180. Is this going to be bigger than 1 pi? It is, because it's bigger than 180 degrees. So really, you're wanting to put 220 on 18 in your calc on over 180. But I wouldn't. That's 22 on 18. I'm already crossing off a 0 just in my head. And they're both even. Sometimes using a calculator takes longer. Aren't they both even? Halve them both. What do you get? Come on. 11 pi on 9. All right. What if I said 308 degrees, and I'm going to do like 425. So 308 degrees. So we okay? So 308 pi on 180, and you'll need to simplify. I do not want a decimal answer. That can be written as a fraction answer. I think you can divide them both by, well, 2 and 2 again. For example, 220 we know is more than 180 degrees, so it's bigger than 1 pi. It's actually 1 2/9 pi. 308 degrees is getting close to 360 degrees. It's almost 2 pi. And this is bigger than 2 pi. It's bigger than 360. So it is bigger than 2 pi, for example. Because 72 pi on 36 is 2 pi. Because 72 on 36 is 2. So now, we also can convert radian measures to degrees. Now, all the radian measures, I don't have to give you radian measures in terms of pi all the time. I can give you just numbers, all right? Because you don't always have a multiple of pi. We'll start off with some pi ones. So let's say I want to convert 7 pi on 9 to degrees. Look, some people, one way you can do it, I sometimes just know that pi is 180 and just change that. But the rule is multiply by what? By? When you want to convert 2 degrees, you write the degree one first. Do you get it? Times 180 on pi. What cancels? What cancels? The pi's cancel. Do you see? When you want to convert something, so that's in radians, you want to convert it to degrees, you times by 180 on pi. Now, what do you get? 7 times 180 on 9, whatever that is. Do you see how the pi's cancel? I don't know. Oh, yeah, because 9 into 180, good. 9 goes into 180 20 times. So it's 7 times 20, 140 degrees. And you know what? That makes sense, because isn't 7/9 almost 1 whole, 1 pi? And 1 pi is 180 degrees. So you would expect your answer to be getting close to 180. Not too close, but that's right. Yes, because pi on 9 is 20 degrees. So 7 pi on 9 is 7 lots of 20. So that's using a common sense mental approach, is that pi on 9 is 180 on 9, it's 20. So see, now I'm introducing the formal measure, but I prefer to use the mental way of doing it. Do you, all right, see, I would just say, well, I know pi is 180. 7 times 180 on 9. That's the other way to do it. Or this is the formal way to do it is to multiply by 180 on pi, and the idea is that the pi's cancel. But then I might ask you, I'm thinking 15 pi on 4. Look, you could Girls, you know what I was doing on the page before with mental methods? Isn't that 15 lots of something? 15 lots of what?
45.
Yeah. Or if we want to use the formal method, it's to multiply by 180 on pi. That is the formal method, which I don't like to use that much. The pi's cancel. Or what I taught you before, we know that pi and 4 is 45. That's really should be, my answer should be 15 times 45, whatever that is. And we will get that. So what do you get? 450 and 225, 675. What do you get? 6 what? Yeah. So can you see both methods? But there really is a lot of merit in using that common sense approach. See, from what I was showing you on the page before, that's really 15 lots of pi on 4. Or I could have done 15 lots of 45. Here I could have done 7 lots of 20. I'll tell you when you have to use the rule bar. 2.13 radians. Now the symbol for radians is this little C like that. How do you convert that? So 2.13 radians. You know how 1 radian we know is about 57 degrees? We don't use that. We just go, well, that's times, sorry, that many radians to degrees, we times by 180 on pi. So in cases like this, you can't use your exact values if I ask you to do 2.13 radians. Now, the only thing is, pi is 3.14, 159, etc. This is smaller. I'm thinking my answer is about 120-ish. What are you going to get? So, girls, it's when you're asked not an exact value like these are exact, fairly like exact, but you're asked something like 2.13 radians. To convert from radians, so this is the symbol for radians. So this is the symbol for radians, like a little C. Radians. You think that one's going to be small? 0.7 times. To convert from radians to degrees, you times by 180 on pi. And I might ask you 7.5 radians. And before you do 7.5 radians, working with radians, just remember that pi is 3.14 something. It's numerical value. So 7.5 is bigger than 2 pi. It's bigger than 6.283. This is like bigger than 2 pi is 360 degrees. This should be about 400 and, all right, no. 2 pi is 360 degrees. That is bigger than 2 pi. Because 1 pi is 3.14, the number value of pi. See, when you look at it like that, you've got to compare it sort of to, you know that pi is 3.14. So, girls, remember you're multiplying by 180 on pi. So tell me what you get for each. This first one should be quite small. 40 to the nearest degree. All right, and what about the next one? Yeah, it's bigger than, the reason is pi is 3.14, 2 pi is about 6.28-ish. That is bigger than 6.28. It's bigger than 2 pi. It's bigger than 360 degrees because 2 pi is 360. What did we get? 400 and? Degrees to the nearest degree. Okay, so what you've got to know for values like this, when you're converting to degrees, you multiply by 180 on pi. How are you going to remember it? Is it pi on 180? Is it 180 on pi? If it's degrees, you write the degree first. Convert to degrees. Write your degrees first over your radians. And if you're converting to radians, write your radians first, then divide by degrees. To degrees, I don't just learn that blanket rule times by 180 on pi. The other thing you can do, if you know that pi on 2 is 90, you know that that's 3 lots of 90, which is 270. Or if you know that pi is 180, you're really just replacing the pi with 180. So that is another way to do it. It's 3 lots of 180 on 2. Do you get that? All right, this one, we already looked, I showed you that originally. You know how 60 is, so see this, the rule, I don't like using the rule. Isn't it easier to say 60 is 180 on 3, so it's pi on 3, rather than doing it like this? Do you get that? I don't like to do it this way. You do? Okay, that's fine. You can do it that way, but as the thing is, when you've got to work quickly, really to do your 30, 60, 45, you're better off knowing that 60 is 180 on 3, so it's pi on 3. Okay? Something like 50 degrees into radians, you've got to, the only thing you really could do is multiply by pi on 180. Okay? We watching? Changing this into degrees, you're timesing by 180 on pi. And if they want it to the nearest minute, you'd have to do your DMS button. Now, let's 3 pi on 2 to degrees. You've got many different ways you can do this. I can think of 3 ways. You could say to yourself that's 3 lots of 90, because pi on 2 is 90. If you want to work quickly, you would do that. So you've got, you know, you could say that's 3 lots of pi on 2, which is 3 lots of 90, which is 270. Or you could say it's 3 times 180, because pi is 180 degrees, over 2. Again, that's 270. Or if you want to use the new formal method that we've learnt, you would multiply it. So change the degrees, you times by 180 on pi, and the pi's cancel. That's the new formal method. These are mental methods, which are quicker. It will take you a bit of time, so that's 270 as well. Now, the next one, to change 60 degrees to radians, see, for me, I would just say that's 180 on 3. Do you know what I mean? I would just use mental methods to know that that's pi on 3. But if you want to use the new method, how do you change to radians? Times by pi on 180. And 60 on 180, you end up with a 3 on the denominator. Okay? With this one, 50 degrees to radians, there's only the one way you can go. You have to use the rule. Okay? So this one, you have to times by pi on 180. There's nothing else you can do. Change 1.145 radians into degrees. What do? Times by into degrees. No, you write the degree first. Okay? To the nearest minute. So off you go, get your calculator out. These 41 minutes, you have to enter it times pi on 180. What do you get? 0.536. And you know this next one? We're going to talk about this one tomorrow, I think, because guess what? You cannot be in degrees mode on your calculator. You need to change the mode on your calculator. Can I have a calculator, please? So, girls, this last one is not in degrees. This is what that new mode on your calc is. Girls, just watching, you go set up. Why can't I see that anymore? And you must go to radians mode. Girls, you have to change the mode to radians. You know how you go degrees. And then you go cos. You'll see the screen. Cos of 1.145, which is, so you have to be in radians mode if it's saying something like cos of 1.145, and I get 0.413. 0.41. 0.41 to 2 decimal places. But if you see a question like this, you must be in radians mode in your calculator. I will send you homework.